So, section 2.8 discusses or introduces one-to-one functions and their inverses. Okay? So, we're going to start out with the definition here. A function with domain A is called a, let me zoom in so I have a little bit more space on the line, or at least it'll look that way, is a one-to-one function if no two elements of A have the same image. That is, if f of x1 is equal to f of x2, then x1 equals x2. Okay, so in other words, no two elements of A have the same image or output. Okay, alternatively, so this is what we use here, or alternatively, some people say or write f of x1 is not equal to f of x2 when x1 is not equal to x2. So that's an alternate meaning for one-to-one. Okay? If you're given a graph, the way we determine if a function is one-to-one, we use the horizontal line test. We use the horizontal line test. Okay, it says a function is one-to-one if and only if no horizontal line intersects its graph more than once. Okay, so in other words, if we take this horizontal line, it's supposed to be a horizontal line. If we take this horizontal line here, does it intersect the graph more than once?
Yeah.
Yes, so is this function one-to-one?
No.
No. Very good. This function is not one-to-one because it does not pass the horizontal line test. Good. Part B. Part B, suppose we have the following functions. In this one, you have a set A of numbers 1, 2, 3, and 4, and you have a set B of numbers 10, 7, 8, and 5. F is your function from A to B. A is your domain, B is your range. 4 gets sent to 10, 3 goes to 7, 2 goes to 8, and 1 goes to 5. Is this an example of a one-to-one function or not?
Yes.
Yes, it is. Yes, because no two elements of A have the same image. So F is one-to-one here. What about this one? Is it one-to-one? Is G one-to-one? No, very good. Why not?
Because on the A side 3 and 2 both go to 4.
That's very good. So 3 and 2 both get sent to 4. So they have the same image, which means that G is not one-to-one. So G is not one-to-one. Okay, so now we know what a one-to-one function is, and we know examples of one. Now we talked about how to find it graphically and with what's called your diagram, your Venn diagrams. Now let's talk about how to find it algebraically. Let's talk about how to determine if whether a function is one-to-one based on the equation that we're given. Okay? So part A here in example 2, we're given h of x equals x cubed plus 8. So remember that one-to-one means, so this is just a quick recall of the definition, one-to-one means that we have f of x1 is equal to f of x2 if we have f of x1 is equal to f of x2, then that means that x1 had to equal x2. So what we're going to do here is we're going to suppose h of x1 is equal to h of x2 in the hopes that we can perform some algebraic manipulation and get x1 is equal to x2. That's the hope. Okay, so let's try it. H of x1 is x1 cubed plus 8. What's h of x2? Good. It's x2 cubed plus 8. Now we subtract 8 from both sides, which means they're going to go away. That's going to leave us with x1 cubed equals x2 cubed. Then we can take the cubed root of both sides, and then that's going to give us what? What's the cube root of x1 cubed? X1, right? So we get x1 is equal to x2 as desired. So that means h is what? Very good. That means h of x is 1 to 1. Okay? Good. Now, b, we have r of t is equal to t to the 4th minus 1. Now, we could go through the same steps, or we can notice that this is an even power, and because this is an even power, what can we say? Do you know r of t, is that going to be 1 to 1 or not? It will not. Absolutely correct. And I see quite a few of you shaking your heads no. So in the case that we already know that it's not going to be 1 to 1, we can write down a specific example illustrating why it's not 1 to 1. That's called a counterexample. Okay? So, we said r of t, is not our answer. We have r of t is not 1 to 1. Negative 1 to the 4th minus 1 is equal to 1 minus 1, which is what? 0. And what can we also say? If we looked at negative 1 to the 4th minus 1, what should we look at now to show that this is not 1 to 1? 0? What does it mean? Remember, if f of x1 equals f of x2, then x1 had to equal x2. So I chose negative 1 for one value. What other value that we choose will give us 0? 1, right? So that's the other one you choose. 1 to the 4th minus 1 is equal to 1 minus 1, which is 0. So here we have f of negative 1 is equal to f of 1, or not f, we have r in our case, right? So let's use r. So r of negative 1 is equal to r of 1, but negative 1 is not equal to 1. So that shows us that r of t is not 1 to 1 here. Okay, so r of t is not 1 to 1. Okay? A definition. Suppose we start out with a 1-to-1 function. We have to have a 1-to-1 function in order for the next information to hold. So we start out with a 1-to-1 function f. Suppose we have that 1-to-1 function that has domain A and range B. Then its inverse function, written as f raised to the negative 1, has domain B and range A, and is defined by f inverse of y equals x, if and only if f of x equals y. So again, I'll read it again. It's a lot to process. F is going from A to B. right? F is going from A to B, is sending x to y equals f of x. F inverse takes B and sends it to A. It takes B and sends it to A. So F inverse of y is going to equal x if and only if f of x is equal to y. Okay? So now we have the definition of an inverse function. An inverse function only exists if f is 1 to 1. So you will always have to make sure your function is 1 to 1 in order for you to find an inverse function of it. Okay? All right. Notation here. Let me not put random marks. I'm trying to move this. F inverse of x does not mean 1 over f of x. You may remember that x to the negative 1 is equal to 1 over x, but this is just a power function over here. This indicates you need to find the inverse of a function. It's different. Okay? Now we're going to assume that f is a 1 to 1 function. If f of 5 is equal to 18, find f inverse of 18. What do you think f inverse of 18 is going to be? 5. Very good, because you have to go back, right? So this is equal to 5. Okay, and we talked about composition of functions, right? So you can actually see that from this viewpoint as well. We know f of 5 is equal to 18. So we can say that f inverse of f of 5 is going to be equal to f inverse of 18. F inverse composed with f is just the identity because they're inverses of each other. So we just get what's on the inside. So we just get 5. Good. So tell me B. If f inverse of 4 is equal to 2, what's f of 2? 4. Good. It's 4. Okay? So I kind of hinted at this property already, but now you have this inverse function property. The inverse function property says, let f be a 1 to 1 function with domain A and range B. The inverse function, f raised to the negative 1, or f inverse, satisfies the following cancellation properties. F inverse of f of x is equal to x for every x in A, right? Because x first have to go into f, and f goes from A to B. Then f of f inverse of x is equal to x for every x in B, right? Because B is the domain of f inverse. So f sends A to B, f inverse sends B to A. Okay? Now, what we're going to do we're going to use the inverse function property to show that f and g are inverses of each other. So in other words, what we're going to do is we're going to show that f of g of x is equal to x, and we're going to show that g composed with f of x is equal to x. You ready? Yes? No?
Yes.
All right, let's do it. So I'm going to move this up a little bit more. And we have the following. F of g of x is equal to f of 2 minus x over 5. Okay, so we took g of x and we put that into this composition. Now, we're going to take 2 minus x over 5 and substitute it in for x here. So we get that's equal to 2 minus 5 times the quantity 2 minus x over 5. Now what happens? What happens here? You have 5 times 2 minus x over 5. Online, you can contribute as well. What happens here? There's a question online. Notice that we can write 5 as 5 over 1. So then that's 5 over 1 times 2 minus x over 5. What happens?
Can we cancel the 5?
Yes, the 5's cancel out. The 5's cancel out. Good. So that leaves us with 2 minus the quantity 2 minus x. Then what do we do? Distribute the negative, and that gives us 2 minus 2 plus x, which gives us x as we want it, where x is in the domain, or for every x, we can just say. For every x. Okay? So we've shown this part now, we need to show this part. Okay? So, G composed with f of x is equal to G of what? Not everybody at once. G of what?
2 minus 5x.
Good. 2 minus 5x. Now we substitute in 2 minus 5x for x here. So tell me what to write. What do we write?
2 minus 5x over 5.
Very good. We write 2 minus the quantity 2 minus 5x over 5. Now what do we do?
Distribute the negative.
Good. That gives us what?
2 minus 2 plus 5x.
Good. All over
5.
5. Now what happens?
The 2's cancel.
The 2's cancel out. And we get what?
5 over 5x.
5 over 5x?
Or sorry, 5x over
5x over 5. Good.
5,
Which
which reduces to x.
reduces to x. Very good. So 5x over 5, your 5's cancel. You get x for every x. We showed that both cancellation properties hold up here, which means f and g are inverses of each other. Hence, f and g are inverses of each other. That's how you use the cancellation property. Okay? What questions do you have? Okay, so now what we want to do is we want to go through the steps on how to find the inverse of a one-to-one function. Okay, so how do we find the inverse of a one-to-one function? Okay, the first thing we do, we write y is equal to f of x. So you're given f of x here, so you'll want to write y equals 7 minus 5x. And then we solve this equation for x in terms of y. We interchange x and y, and then the resulting equation will be y equals f inverse of x. Sometimes in some books or some places you can interchange these last two steps you'll see some people say write y equals f of x, interchange x and y, and solve the equation for x in terms of y, and then the resulting equation will give you this. Either one will work, okay? So, let's do part A. We have to find the inverse function of f of x equals 7 minus 5x. Before we take these steps, what should we confirm or verify? No, that's the first thing we would have to write. But in order for us to even find the inverse function, what do we need to know about f?
One-to-one function.
It has to be one-to-one. Is this function a one-to-one function?
Yes.
Yes, why?
Would it pass the horizontal line?
It passes the horizontal line test. The graph of this is what? Linear, right? It's linear, which means it passes the horizontal line test. So f of x is one-to-one. Sometimes we write one-to-one like that. F of x is one-to-one since it is a line and it passes the horizontal line test. Okay? So, now we go through those steps. Now we write y equals f of x, and then we find the inverse. Okay? So, we have y is equal to 7 minus 5x. And now we're going to solve this equation for x in terms of y. So, that means y minus 7 is equal to negative 5x. And now we do what to both sides? Divided by what? Negative 5? Negative 5, right? So you get x is equal to negative 1/5 y plus 7/5. Okay, so we solve for x in terms of y, and now we need to do what? So we did 1, we did 2, now what do we need to do? Interchange y and x. So we have negative 1/5 x plus 7/5 is equal to y. And then the resulting equation is y equals f inverse of x. So in other words, y equals f inverse of x this way. And this is your final answer. So negative 1/5 x plus 7/5 is the inverse of 7 minus 5x. That's the inverse function of 7 minus 5x. What questions do you have? Okay. Part B, and I will zoom in this way and move it up so you can still have that on the screen if you wish. Okay, so here we have f of x is equal to 3 minus 4x over 8x minus 1. We agree that f of x is 1-to-1. So we can go ahead and start by writing y is equal to 3 minus 4x over 8x minus 1. Then we multiply both sides of this equation by 8x minus 1. I'll cross multiply. That gives us y times 8x minus 1 equals 3 minus 4x. Now we distribute the y, and we get 8xy minus y is equal to 3 minus 4x. And then our goal now is to solve the equation for x in terms of y, right? So we have to isolate x. So let's get our x terms on one side together. So we have 8xy plus 4x. That's going to be equal to 3 plus y. Then our goal is to isolate x, so let's factor out an x. That leaves us with 8y plus 4 times x equals 3 plus y. And we divide both sides by 8y plus 4. So we get x is equal to 3 plus y divided by 8y plus 4. And now what we do is we interchange x and y. So we have y is equal to 3 plus x divided by 8x plus 4. But y is equal to f inverse of x. And there you go. That's the inverse function of the function 3 minus 4x divided by 8x minus 1. What questions do you have? Okay. So we have one more idea to discuss, and that is of finding the inverse of a function based on the graph of a function given. Okay? So the graph, so a fact, the graph of f inverse is obtained by reflecting the graph of f in the line y equals x. So, in other words, if you have a function given like this, f of x, then the inverse, you find the inverse of that function by reflecting it about the line y equals x. So that's your line y equals x. Reflecting that graph, reflecting the red part, gives us that. So this would be f inverse of x. That would be f inverse of x. So notice that if the point AB is on this line, or is on the graph of f of x, then that means the point BA is on the graph of its inverse. Okay? So that's how we obtain the graph of the inverse of a function. Okay? So now what we're going to do, we're going to go through an example where we're going to apply this idea. We want to sketch the graph of f of x equals the square root of x minus 2 in part A. What does this do to the graph of the square root of x? It shifts it right by 2. Good. So we have 2 here, and then that's our graph. So this is the graph of f of x equals the square root of x minus 2. Now, we want to use, in part B, use the graph of f to sketch the graph of f inverse. Would you like me to draw that on the same graph here?
Yes.
Okay, so we can use a different color. You want me to use the same color I used before?
Sure.
Above? So, reflect it across the line y equals x. When you reflect it across the line y equals x, you're taking this and you're moving it over here. You're moving it over here, right? So instead of 2 to the right, we're going to do what? Go to the left or up 2 from the origin? Left or up? Say it again.
Left.
We're going left. What point is this? What point is this? Let me use red. X is 2. What's y? 2, 0 is on the graph of f of x. This information that I talked about up here says what point should be on the graph of its inverse. 2, 0 is on the graph of f of x. What point should be on the graph of its inverse? 0, 2. So that means instead of going left 2, we go up 2 from the origin. So we go up 2. This point here, that point is 0, 2. Okay? So then, reflecting it looks like that. It looks like that. So you moved this point here, and you draw the same thing. It's the mirror image. Think of you standing in front of a mirror, and what you see, you get back. Okay? So that's part B. So I'll just circle this to indicate that B is that graph. And now, what we want to do is we want to find an equation for f inverse. In order for us to find an equation for f inverse, what do we need to know about f? Is this 1 to 1?
Yes.
Absolutely. The red part is 1 to 1. It passes the horizontal line test. So f of x is 1 to 1. It passes the horizontal line test. And now we go ahead and follow our steps that we just talked about for finding the inverse of a function. We have y is equal to the square root of x minus 2. Notice that y has to be greater than or equal to 0, right? Because we have to have what the radicand has to be greater than or equal to 0, okay? So we square both sides. That gives us y squared is equal to x minus 2. Remember, now we're solving for what variable here? X, very good. So you have y squared plus 2 is equal to x. But now we have to have that y is greater than or equal to 0 still. But now we interchange what? Y and x, good. So that gives us x squared plus 2 is equal to y, which equals f inverse of x, and that is it. But remember, we now have our equation in terms of x, so that means that x has to be greater than or equal to 0, right? Because remember, the domain of your original function f is the range of your inverse function, okay? So that's why we have to make sure y greater than or equal to 0 becomes x greater than or equal to 0. All right, that's section 2.8, which is 1-to-1 functions and their inverses.